exposure, where long was roughly a quarter second. The one on the right, 1/500th of a second. You can get it to blur out. You can use this to your advantage if that's the effect you're going for. On the other hand, this is how you get the wobbly blurs of photos that sometimes show up when you're running with automatic and it decides, not enough light. Let's do a quarter second exposure. And all you see is blur. If you know what's going to happen, that's one thing. If you don't know what's going to happen, it's going to make your life unpleasant and you're going to end up with hundreds of photos that you don't want. This was my story of Nauticon last year. I ran around without a flash taking photos. Of the 400 I shot, I think I got a dozen. We're going to get to that too. That's the scary part. You're absolutely right. Okay, settings are a balance. You can exchange one of these settings for the other. Given a particular lit environment that you're trying to take a picture of, and you figure out these settings work, the exposure is right, we get enough light in, but not too much, mind you, and it falls right in the middle of what my film can handle, you can sit there and swap it around and change the settings for that environment. This is an example. These two settings will give a equivalent exposure, which is the amount of light that actually hits the surface. It'll look about the same. However, the first one is a reasonably long exposure, so if you're trying to get a picture of a car whipping by you at 60 miles an hour, it's not going to look very nice. But if it's still, and the object that you're shooting a picture of isn't moving, you'll probably be fine, and it will be more clear because it has a lower ISO number, less noise in the image. The other one will do a better job stopping the motion of whatever it is you're looking at, but it will have more noise. Same thing here, ISO 100 both times, but you can move up and down and f-stop. Okay, I'm going to jump back to f-stop for just a moment. The f-stop is a fractional stop value, which is designed so that you can move up or down one and double or divide one of the other values by, or divide one of the other values by 2. So these were set up, the fractional values are arbitrary numbers that happen to make that work for the aperture. At some point, you just memorize them and work with it. But we're in the modern age. The best part is you don't have to. Your camera already knows, which makes it a lot easier at this point. So yes, f3.5 and f4.5 are in fact a doubling. So, okay, I have to look at this again because I don't recall how I built this slide. Yes, f3.5 is actually double the light getting through to the image sensor as f4.5. That's where they are. Works. I don't ask. Okay, now this is where we enter the modern age and make it so that we don't have to think about this as hard anymore. Every camera that you can buy today, short of exotic hardware. So you walk down the aisles at Best Buy and you look at the cameras they sell you, they have a light meter in them. The light meter has the ability to look and monitor the light entering the lens, figure out how much is there, and take a stab at how it should be set up for the various 3 settings that I just threw at you. These are remarkably good. The trick is whether they're doing what you want them to for your environment. So typically, the way a light meter will set up, it'll look at the light coming in and try and give you the best aperture opening, which means the most light coming through the lens, at the, okay, back up. It will set it up so that it will let the most light through the lens, which means you can run the shortest shutter speed possible. Because a lot of people, like me, shake, and holding a quarter second exposure still handheld is somewhat challenging. I honestly don't know anyone who can do it. I can sort of do it when I have enough caffeine in my system. But here's where it gets fun. Most of your cameras have a knob which will let you exchange aperture for shutter speed and change that ratio, which allows you to adjust your depth of field and your shutter speed. Most cameras have a second knob somewhere on them that will allow you to say, okay, I want you to intentionally make this exposure worse, or wrong choice of words. I want you to intentionally make this underexposed or overexposed. And thus you can say, overexpose this and give me a wide open aperture, which will give you a overblown image with a very short depth of field. Or you can grab the knob and twist it the other way and say, underexpose this image intentionally, make the aperture really small, and thus make the exposure very long, which is awful handy if you're trying to photograph, for example, stars, which I assure you are a challenge, particularly through normal lens. Okay. Key point. There is more than one way to monitor and analyze the light coming through the lens. You can meter the light at the point your camera chooses to focus on. You can meter the light across the entire image. You can meter the light inside a little circle in the middle of the image. These are common modes. You need to check the manual for your camera to understand how it meters light. I can't tell you, I don't know your camera. Seriously, check your manual. This is useful information and it lets you change and understand what it's seeing. If you ever get horribly overblown photos, it's partially the lighting environment, but often because the camera thought the room was darker than you did, based on its understanding of what you were pointing the camera at. Okay. Digital cameras. Zoom. How many of you know how much zoom your camera can do? Okay, cool. What does that mean?
Optical zoom or digital zoom?
Well, I'm not even worried about that. What's zoom mean? Right. But can you actually quantify for me what exactly the difference between a 3x and a 4x zoom is? What's the difference in the optical elements? How does the image change? Bingo. That's what I was going for. Zoom is an interesting term that's come about recently because not everybody is shooting pictures on the same imaging sensor. I don't have a slide for this, so I'm just going to have to talk about it. So focal length is the interesting number that we're going after. And that comes up to how you do optical zoom. Optical zoom, in the normal sense, is an adjustment of the focal length of the lens to the imaging sensor. This results in a smaller angle of exposure from the light entering the lens. So this is my block diagram that I promised you all that would be coming back. It will probably come back to haunt me later. The first is, we're going to declare that 1x. The second is 1.5x. The point of this is the lens is moved further to what you would see as your right. The lens moves further to the right. That means there's a longer focal length. This means the angle of light that's entering the lens becomes smaller. That's what zoom is. Rephrase. That's what focal length change is. Now, how big is the imaging sensor? Long time ago in a land far, far away, time that's almost past us, everybody shot 35 millimeter film. You worked in the 35 millimeter realm. You knew that your imaging surface was the frame of a 35 millimeter film. So focal length was an interesting number. Now the imaging sensor can be as big as that. It can technically be bigger, but that's rare. But often it's smaller, and often it's much smaller. A focal length and an imaging sensor size interact. When everybody had the same imaging sensor size, you could just talk about a focal length, and it would make sense, and you would have an idea of how wide or how narrow that angle of light entering would be. Everybody's sensor sizes changed. So a focal length by itself doesn't tell you anything. Thus we are reduced to, my camera does 4x zoom. grand. What's the angle of entry of the image coming in at that point? That strikes me as being more useful than 4x, because I never quite can tell, is that mean you can narrow the angle to 4 times as narrow as your widest point? Does this just mean you have no really wide angle? Does this mean you have only narrow angles and can go really narrow? Zoom is a horrible number which tells you nothing about how the camera can actually view. Angle, that would be a useful number. I don't see that published very often. Okay, so back to my slide. Optical zoom. You slide the lens forward and backwards. Sometimes it can do this inside the camera itself. Sometimes, example, this camera, it actually slides elements in and out. What this ends up doing, like I said, narrower field. Then you might have heard of this horrible thing called digital zoom. The elements don't move. The camera takes a subset of the imaging sensor, says, I'm going to take this section, my imaging sensor is this big, I'm going to take this section and in software scale it up. This isn't higher resolution pixels, I'm sorry, there's the same number here as there would be if I was capturing all of them. So you're capturing this much and blowing it up. Limited number of pixels there, and now we're making them and interpolating and guessing harder. Almost consistently, digital zoom is a horrible mistake unless you are going to do zero editing on your photos. If you will never ever edit your photos and you're just going to take them off your camera and put them on your Sony television that can read memory sticks or something like that, okay, digital zoom might make sense. But if you are willing to do any level of post-processing, digital zoom will only make your life bad. Don't use it. Shut it off. Most cameras have a knob which says no digital zoom. Solves it. Okay. Flash photography, or how I've been blinding people all day. Essentially, it's a light source that we synchronize with the opening of the shutter. This brings up an interesting term, which is minimum sync speed on your camera. For flash photography to work, we have to set off a light, very bright, during the precise moment that the shutter is open on the camera. When the shutter is open all the way, because we have one burst of light to work with, you set it off. Most cameras can do very, very fast shutter speeds. Mine goes down to 1/2000th of a second. However, it does this by having the opening shutter trail down and the closing shutter trail after it. So what happens is there's a very narrow slit that's actually open during any given time. Problem is, the flash fires instantly during this slit somewhere. So what you would end up with was a band of actually lit section across the photo, and the other parts are unlit. So what happens is there's a minimum speed for flash sync, which my camera, 1/200th of a second. That seems to be pretty common. What this means is the distance, okay, now I have the entire frame open, I can fire the flash. Now I close it. That's the fastest shutter speed you can run when doing flash photography. Here's the great news. Most cameras won't let you set it in a state where it won't work right. Thus, you don't have to worry about it much. But if you're wondering why your camera with the flash open won't go over 1/200th of a second, or 1/100th of a second, or some other arbitrary number, when you take the flash off, it goes to a much faster shutter speed, that's why. Okay, flashes typically have a very hot color temperature, which makes them look blue. Pictures taken with flashes will look bluer than pictures taken with natural incandescent light or natural light. And I am not going to talk about color temperature for the simple reason that this dives into a deep, dark corner of how we represent color, human perception, and other scary things that make me crawl into the corner and scream in agony. I have spent hours of my life trying to get my monitor color accurate. I gave up.